Okay, so let's look at this question. It's essentially asking us to look at this compound, so the hydrogen peroxide, and it's asking us, does it have a tendency to disproportionate? Well, as we know, that essentially what we need to do is we just need to look at whether or not the reduction potential on the right is larger than the standard reduction potential on the left. And we can immediately see that because, we can see that 1.76 volt is larger than 0.70 volt. So in other words, yes, hydrogen, yes, yes, hydrogen peroxide will disproportionate. Another question is further, why exactly is this? Well, it is because if we look at the cell potential that arises from this situation, in other words, what is the reaction? So there is some reaction in which hydrogen peroxide then has an equilibrium with oxygen and water. And of course, you can balance this. So you can clearly see the oxygens and the hydrogens aren't balanced. So you can go and do that on your own. But essentially, the question is now, then what is the cell couple's potential? So in other words, that is E naught cell is then just equal to 1.76 minus 0.70. And that is just going to give you a positive number. It's essentially where I wanted to get to. So this is a number larger than 0. So in other words, your E naught cell is larger than 0 for this equilibrium. In other words, it will be product favoring. And if it is product favoring, then it means that this equilibrium, so in other words, the one here, will of course have a tendency to occur. So in other words, and what is the reaction actually? It's a disproportionation reaction. So in other words, that is why H2O2 has a tendency to disproportionate. You can further argue it in terms of the Gibbs energy or even the equilibrium constant, but essentially they all just indicate the same thing. And that is that, yes, it will disproportionate, and you just need to be able to recognize whether or not something on the right and the left, or something on the right is larger than something on the left. That's the basic idea, but the explanation behind it is that the equilibrium that then forms, in other words, H2O2 tending to that, has a cell potential. So in other words, just like you write your other reduction potentials, you can calculate this cell potential. And if that is positive, it means your equilibrium is product favoring, and hence there's some other things to that as well. Okay.